So this is mostly your hour. I'm going to blab just a little bit, and then after that, I'll just let you ask questions. So just to where we're at. Whoops. Drop this. Okay, so if you want to start putting stuff into the chat, you may for review questions. But basically, I'm done with the semester. We're here. Okay, so reminder, tomorrow is our last regular test. You turn in all of this. 70% homework requirement. You must turn in at least 70% of the homework in order for me to grade your test. You don't have to worry about any homework for the final exam. Final exam is just the final exam. Okay, so as usual, a little bit after 12, I'll send the test through Canvas announcements, but I'll also project it for some of you who like to have it projected. Maybe that's a little bit better for you. Then Friday, we will just have a question and answer session for the final exam. So the best way, the most productive way to do Friday, I think, is to come in with old exams and then ask me questions about previous exams. Again, for the actual test tomorrow, I'm not promising I'll finish grading your test by Friday. I'm going to try, but if I don't, I still have the weekend to get it for you. But at least I'll try to get you the solutions. I'll make a video and have the video ready for you by Friday so that you can kind of grade yourself on how you did for that. Okay, and again, then our final exam, most likely I'll take maybe 3 or 4 questions from each exam. So if I take 3 questions from each test, that'll be 15 questions. If I take 4 questions from each test, that'll be 20 questions. Okay, so next Wednesday, starting time is 11:10 to 1:40, not 12:10. So 11:10. Again, all that's going to happen is I'll send the exam through Canvas announcements, and you would just log in as usual. I'll proctor, and then when you finish, turn it in, then we're done with the course. Okay, so that's pretty much all that. Okay, and you know what to turn in. You turn in all of this for homework. Okay, so I think that's pretty much about it. So I'll go ahead and get started. So I'll check the chat. There's no lecture today. Of course, I would say, if you don't ask me questions, I'll threaten to do more material. And then I started thinking about, wait a minute, there is no more material. We're finished. Okay, so if you have no more questions, then that's pretty much it. Okay, all right, let's see, 5.527. Okay, so let me just use. Okay, so go ahead and put as much as you want on the chat. 5.527, 5.429, sorry, 5.459. B. Okay, and that's all I see for now. If somebody asked about attendance. Again, send me an email once I put away the attendance. I'd like to take it back out. So, all right, so I have 2 questions right now. So I'll do the 2 questions, and if nobody else has anything, we're finished. Okay, so 5.527, 5.459. Okay. And let's see, there's what, 1, 2, 3, 4, 5, 6 sections. So at least 1 per section. Well, 5.3, we had the fundamental theorem of calculus part 1 and fundamental theorem of calculus part 2. So for sure, there should be 2 questions on 5.3, one on FTC 1 and one on FTC 2. Okay. But yeah, so 1 question from each and maybe a couple more from others. Right. No doubt you're going to have some more integration ones. We did some integration, but I'll have you do the pre-integration stuff, like chop the integral up into so many pieces and do either a left sum or a right sum or a midpoint sum, something like that. It's possible. Okay, and let's see, 5.11B was asked for. Okay, so why don't I go ahead and get started with that. I'm going to turn off the chat so I can see what I'm doing. But, okay, 5.527. 5.527 is what? X squared plus 1 x cubed plus 3x to the 4th power. Okay. So substitute. The derivative of this is almost this. And how can you tell? That's third degree. The derivative of something with third degree is second degree. So u equals x cubed plus 3x. So I automatically made it easier, right? Instead of doing blah, blah, blah to the fourth power, it's just u to the fourth power. du is 3x squared plus 3 dx. And if we take a look at this and this, if I factor out the 3, then I have that, right? So 3 times x squared plus 1 dx. Okay, so I can get it a match if I put in a 3. So you can do this for constants, but not for variables. So 3 inside, 1/3 outside. So my integral now has 1/3. X cubed plus 3x is now u to the fourth. 3 x squared plus 1 dx. 3 x squared plus 1 dx du. And look at how easy that is. So 1/3 u to the fifth over 5 plus a constant. 1/15 parentheses to the fifth plus c. And now instead of writing u, write what it was equal to, which is x cubed plus 3x. X cubed plus 3x. And that's that. Okay, 5.459b. 5.459b. V of t is 3t minus 5. Right, this was the one where there's a difference between displacement and distance. So it just becomes a geometry question, essentially. If you plug in 0, you get -4. Where does it touch the x-axis? At 5/3. And when I plug in 3, I get 4. 1, 2, 3, 4. Four, 5/3, 0. So this is 5/3. This is 4. Oops. 5. 0, -5. This is 4. And this is 4/3. So the total distance, part B, is 1/2 of 5 times 5/3 plus 1/2 of 4 times 4/3, which is 25 over 6, plus 16 over 6, which is 41 over 6. And then just get the correct units, meters. Okay. You might recall for part A, the displacement is the difference between these, so the displacement would be 9 over 6, or 1/2. 5.1, can't read my own writing, I think it's 1b. 5.1, 1b, yes. Okay. 10 rectangles. Okay. So I can't write and read this at the same time. Maybe I'll just tell you the process but not write anything down. Sorry. But for upper estimates, looks like you can use the left endpoint. Okay, so delta x is 1. The left endpoints are going to be, I would say, 5, 4, 3, 2.5, 1.8, 1.2, 0.9, 0.4, 0.2, and 0.1. Just add them all up. Okay, and then the lower estimate, delta x is still 1. Then I pick the right endpoint. So they're going to be 4, 3, 2.5, 1.8, 1.2 maybe, 0.9, 0.5, 0.3, 0.2, and 0. Okay, I didn't have time to write them down, but it's being recorded. You can catch what I said there. So that's how you would do 1B. It's kind of awkward because I have to show you this, so I can't write at the same time. But that's as much as I'll do for 1B. Okay. Okay, so I'm done with that session. Now let's see what else there is in the chat. 5.517, 53, 59, 5.3, 17, 39, 43, 13, 5.4, 43, 4.9, 45, 47, 13. Okay. Well, that gives me something to do now. Okay, so I'll turn off the chat. Okay, and sometimes during the chat, I might miss your question because it's hard for me to look back and forth and make sure I covered everything and so try to show you the problem. So if I miss your question, just go ahead and ask it again. Okay, so that's over. 5.5, 17. Integral of e to the u over 1 minus e to the u squared du. Okay. The derivative of the bottom is almost the top. And since I've already used u, I've got to pick a different letter. So how about v equals 1 minus e to the u. dv is negative e to the u du. And how come I can't use my favorite u? There's already u there. So I have to pick a different letter. Negative 1, negative. So I is negative integral of negative 1 e to the u du is dv over v squared, which is negative integral of v to the negative 2 du, which is negative v to the negative 1 over negative 1 plus c. Two negatives make a positive. So I have 1 over v plus c. And 53, 5.5. Cosine pi t over 2. Integral from 0 to 1. Cosine pi t over 2. I'm going to write it like this. Okay, I could do a u substitution. I'm going to try to show it to you by going directly with the inverse operation of the chain rule. If I were differentiating this, when I got to this stage, I would multiply by pi over 2. Therefore, when I integrate, I divide by pi over 2 or multiply by 2 over pi. Okay, so sine pi over 2t times 2 over pi. That's much faster. Your Calc 2 teacher might insist that you know that shortcut. So yes, you could do a u substitution, but just think of going backwards for differentiation. If you were to ask for the derivative, when you get to this stage, you would multiply by pi over 2. Therefore, when you integrate, you do the opposite. You divide by pi over 2, which is multiplying by 2 over pi. That works only if you're multiplying by a constant in the chain rule. Not for variable expressions, but for constant expressions, that works. Okay, so 2 over pi. Plug in 1. Sine of pi over 2 is 1. Plug in 0. Sine of 0 is 0. So 2 over pi. Okay, and 59. E to the 1 over x squared dx. Let u be 1 over x, which is x to the negative 1. Du equals negative x to the negative 2 dx, which is negative 1 over x squared dx. Okay, so I need a negative 1 inside and outside. Like that. X equals 1, u equals blank. X equals 2, u equals blank. Okay, plug in 1, 1. Plug in 2, 1/2. So I'm integrating from 1 to a half, which is backwards, but that's still going to be okay because there's a negative outside. So 1 corresponds to 1, 2 corresponds to a half. Okay, this is backwards, but you can tell what I'm going to do the next step. I'll just flip it and make it a positive. And then it'll be the way that I want it. So e to the 1 over x becomes e to the u. And then negative 1 over x squared dx is du. So you're going to go from 1/2 to 1 of e to the u du, which is e to the u from 1/2 to 1. So that's e to the 1 minus e to the 1/2, or e minus radical e. Okay, let's see, 5.3 was asked for. 5.317. Y equals integral radical x to pi over 4. Theta tangent theta d theta. So this is FTC1. It's supposed to be constant on the bottom, variable on the top. So negative, switch it. Pi over 4 radical x, theta tangent theta d theta. So y prime is negative radical x tangent radical x. Plug in radical x right there and right there. And then by the chain rule, it's times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, which is negative radical x tan radical x over 2 radical x. Radical x cancels out. So negative 1/2 tangent radical x. Okay. And 39 was asked for. One over radical 3 to radical 3, 8 over 1 plus x squared dx. Pretend 8 is 8 times 1. This is your arctangent. Inverse tangent of x, 1 over radical 3 over 1. So it's 8 times inverse tangent of radical 3 minus inverse tangent of 1 over radical 3. Okay, I'm pretty sure we did this before. This comes out to be pi over 3. This was pi over 6, I believe. Let me just talk about this quickly. Inverse tangent of radical 3, call it theta. Tangent of theta is radical 3 over 1. Sine theta over cosine theta is radical 3 over 1. Divide top and bottom by 2. That means sine of theta is that, cosine theta is that. Theta is 60 degrees. pi over 3. And do the same thing for this one, you get pi over 6. Okay, so anyway, I have 8 times pi over 3 minus pi over 6, which is 8 times pi over 6, or 4 pi over 3. Okay, and then let's see. 5.343 was not on the list. 5.343, so I'm not going to do that one. 53. 5.353 is also not on the list, so I'm not going to do that one. 5.313. Whoops. Yes. 5.313. Then you go from 1 to e to the x of ln t dt. Okay, variable on top, constant on the bottom, that's the way I want it. Plug in e to the x and then multiply by the derivative of e to the x for h prime. So h prime is ln e to the x times the derivative of e to the x, which is itself. And that gives me x e to the x. So that's that. Okay, 5.443. 5.443. And go from 0 to 1 over radical 3. T squared minus 1 over t to the 4th minus 1 dt. This factors in a t squared plus 1, t squared minus 1. T squared minus 1 over t squared plus 1, t squared minus 1. And these cancel out. So 1 over t squared plus 1 dt. That's my arctan. Zero to 1 over radical 3. So inverse tangent of 1 over radical 3, we just talked about that, minus inverse tangent of 0. Inverse tangent of 0 is 0. Okay, and the trick here, look at what we just did 5 minutes ago. That comes out to be pi over 6. Okay, 4.9. 4.945. F double prime. E to the x minus 2 sine x. F of 0 is 3. F of pi over 2 is 0. Okay, so f prime is the first antiderivative. E to the x minus 2 sine x, which is e to the x plus 2 cosine x plus c1. Double check the derivative. Derivative of that is that. Derivative of 2 cosine x. Yeah, we're good. Okay, got to go back up. Integrate one more time to get to f. So f of x is the integral of that thing. E to the x plus 2 cosine x plus c1 dx, which is e to the x, integral of 2 cosine x, 2 sine x plus c1x plus c2. F of 0 is 3. So I plug in 0. E to the 0 is 1. Sine of 0 is 0. Put a 0 here, that's 0. Plus C2. 3 is 1 plus C2, that means C2 is equal to 0. 2. Yeah, C. Okay, so now I say f of x is e to the x plus 2 sine x plus c1x plus c2, which is 2. Now I plug in f of pi over 2 equals 0. F of pi over 2 equals 0. Means 0 is the answer when I plug in pi over 2. E to the pi over 2 plus 2 sine pi over 2 plus c1 pi over 2 plus 2. Okay, well, that's kind of clumsy. Sine of pi over 2 is 1, so 2 plus 2 is 4. E to the pi over 2 plus 4 plus pi over 2 c1. Real clumsy. Pi over 2. Yeah, let me just go with it. So throw these two over. Negative e to the pi over 2 minus 4 equals pi over 2 c1 multiplied by the reciprocal 2 over pi. 2 over pi. So c1 is 2 times e to the pi over 2 minus 4 divided by pi. Very awkward. And there should be a negative there too. Okay, so that gets plugged right into, oops, not there, into there. And then I have my final answer, in theory, unless I made a mistake. So final answer, f of x is e to the x plus 2 sine x plus c1, which is this weird thing, 2 over pi negative e to the pi over 2 minus 4 x plus 2. Okay, 47. F double prime is x at negative 2. X is greater than 0. F of 1 and f of 2 are 0. Okay, so f prime of x is the integral of x at negative 2 dx, which is x to the minus 1 over minus 1 plus c1, which is negative 1 over x plus c1. F is the integral of negative 1 over x plus c1 dx, which is negative ln absolute value of x, but they told me x is greater than 0, so I don't need the bars. Negative ln x plus c1x plus c2. Okay, f of 1 equals 0. Means 0 is the answer when I plug in 1 here and here. So negative ln 1 plus c1 plus c2. ln 1 is 0. That means c1 plus c2 equals 0, or c1 is the opposite of c2. F of 2 equals 0. 0 is the answer when I plug in 2. So negative ln 2 plus 2c1 plus c2. So move that over. That means 2c1, whoops, 2c1 plus c2 is equal to natural log of 2. c1 plus c2 equals 0. So if I subtract, I get c1 equals ln 2, which means c2 is negative ln 2. Okay, so I put those in.
सबैजनाकाममा छ आज म मात्रै आज काम नौ
Everybody please keep muted. All right, so plug those in. So So f of x is negative ln x plus c1x, x ln 2 minus ln 2. Okay, so that's the answer to 47. And then it looks like 13 was asked for. Sneak that in here. 13, you want the integral of 1/5 minus 2 over x. Dx. So 1/5 x minus 2 ln absolute value of x plus c. That's pretty much about it. Remember, 2 over x is 2 times 1 over x. So the integral is 2 times ln absolute value of x. And there we go. Okay, so I think I've caught up with that batch. Let me check to see what else do we have. Okay, negative 5.517. Okay, that was a while back. I don't know where that is anymore. 5.517. Okay, I'm not going to be able to find it fast. Maybe the best way to do it is just go back and start over at this stage of the game. 5.5. Find it. So I'm just going to pretend the problem starts all over. And otherwise, I'm done with this. So if anybody else still wants to ask something, go ahead and put it in the chat. Otherwise, we're finished. 5.517. Where did -1 come from? Okay. I'm assuming you have it. I know I did it today. It's just going to take me a while to find it. But it's in the notes. So e to the u over 1 minus e to the u squared du. So v is 1 minus e to the u. What is the derivative of 1 minus e to the u? Negative e to the u. Oops, that's e to the u. So that's why I need to put a -1 inside and outside in order for it to balance. Okay. So there we go. Okay, when can you submit the homework? You can submit it now if you want. Okay, so I think this answers somebody's question on where the -1 come from. It's required. I can't substitute for dv until I see a negative there, because the derivative of 1 minus e to the u is negative e to the u. The original problem didn't have a negative, so I put a negative inside and outside. Okay, I think I caught up with the chat, but there were so many questions at the beginning, I might have missed somebody's. So if I missed your question, I apologize. Just go ahead and ask again. But otherwise, I'm finished. Okay, so I'll wait a moment. So you can unmute yourself and ask the question, or put it in the chat. And if I don't hear anything, then we're finished, and then I'll see you all for the test tomorrow. So anybody else, please? Okay, seeing nothing and hearing nothing, then I'll stop. Okay, so we're finished, folks. So we'll be ready for the test tomorrow. And Friday, ask questions from previous exams, and then we're done. All right, that'll do it for today, folks. So everybody have a good afternoon, and we'll see you tomorrow. Bye, everyone.